Welcome to Carlton's Math Corner. Today we're going to discuss geometric sequences. At this time, please make sure that you have your math journal, vocab packet, as well as something to write with. Our target today is I can determine if a sequence is geometric. Well, in front of us we have groups of smiley faces. In the first group we have 2, then 6, then 18, then 54. And I want you to make some observations, like how did we go from one group to another? Like, what is the pattern? Well, what I notice is that if I start off with the first term or the first group, there are 2 in that group. Well, if I take that 2 and I just highlight it in this next group, I notice that it takes 3 of them to get to 6. Then if I take this group of 6 and I highlight that in this group, I notice that it takes 3 of these, see there's 3 6s, to make 18. And then if I take 18, which, okay, here's 8, 12, 16, 18. If I take 18 of these, I noticed that there are also 3 of those groups. There's 3 18s in 54. And the way that I knew that, and I can confirm it, is if I say how many 2's go into 6, well, 6 divided by 2 is 3. How many 6's go into 18? Well, 18 divided by 6 is 3. And how many 18's go into 54? Well, 54 divided by 18 is also 3. And so this actually shows you what a geometric sequence is. A geometric sequence is just a sequence that has a common ratio between their terms. So when I divide, the terms together, I get the same ratio each time. Okay, so let's look at a couple examples. Make some observations. What steps do you notice? Well, I notice that the steps are very similar to what we did in the arithmetic sequence. In the arithmetic sequence, we started with the second term because we always start with the term that follows, and we ended up subtracting by the first term to see if it had a common difference. Well, this time, we're checking to see if it's geometric. So it looks like we are now dividing instead of subtracting. And so we start with the second term, same as arithmetic, 1 divided by 1/2. Now, in a prior unit, the real numbers unit, we learned that to divide fractions, we need to do a keep, change, switch. And so when I do that, basically this problem turns into 1 times 2, or 1 times 2 over 1. And 1 times 2 is 2. Then if I take 2 divided by 1, 2 divided by 1 is 2. 4 divided by 2, 4 divided by 2 is 2. And then 8 divided by 4, lastly, is 2. And so notice this one is considered a geometric sequence because all of the quotients are the same. Now, when we look at this sequence, we're going to do the same steps, start with the second term, 2/3. 2/3 divided by 1/9. Well, remember, keep, change, switch. And what happens is this turns into 2/3 times 9, or 9 over 1, and which is 18/3, or that simplifies down to 6. Then if we look at the following term, so that would be 2. 2 divided by 2/3. 2 divided by 2/3 that gives us 3. Now I want you to notice that that is a different quotient than what we had before. The first quotient that we got was 6. Now it is 3. And notice it remains 3. However, the 6 is different than the rest. And so because of that, this is not a geometric sequence. Okay, all of the quotients have to be the same. That's why it's very important that you try each of the terms, because it only takes one of them to be different to make it not a geometric sequence. Okay, so let's look at our steps. So first thing we did, we divide the term that follows by the first term. So always start off with the one that follows divided by the one before that. And that's just to see if the quotients are common or uncommon. If they are the same, then it's geometric. If they are different, then it's not geometric. And remember, if you're working with fractions, remember to do keep, change, switch so that you get the correct answer in the end. At this time, what I would like you to do is just try out 2 problems. Check these sequences out, divide the terms out, and see if they are a geometric sequence. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.